الآن مع ورقة علمية يقدمها لنا مستر مارك كينج بعنوان 3D Digital Reality. Just want to give you a brief about his position. Mr. Mark is a reality capture and BIM solution, and he's a manager like at a Geosystem. Welcome.
Afternoon. My name is Mark King. Thank you for the introduction. And I'm honored to be here this afternoon to present about 3D digital realities. As I've said before, I work for Leica Geosystems. I'm the reality capture and BIM segment manager. And I've been working with 3D laser scanning, mobile mapping, as well as BIM and GIS for the last 10 years. And I've been working with Leica for 5, and I've recently, in the last 18 months, I've moved to Dubai, and I'm fairly new to the region. So be gentle on me, because maybe I ask you there. Today I want to cover very quickly about digital realities and how we see a huge trend globally in the adoption of solutions that allow us to capture 3D reality very, very quickly to provide 3D data for your deliverables. This is where I live now, and there's a very famous saying, the only constant in life is change. And for Dubai, and to be honest, the whole region, I've traveled a lot of it now, everything is changing very, very quickly, to the point where the tools and the technology and the solutions that we use have to be equally quick to keep up with that change. Whether that's new buildings, new infrastructure, new roads, new rail, everything we do every day has to be that much quicker so that we can deliver to our customers exactly what they want when they need it. But how do we deliver this change? And for us at Leica and our partners, SurveyTech, there's 3 parts. One is obviously there's lots of new technology. We as a manufacturer, we provide a lot of new technology, but that's, in our mind, only one piece of the puzzle. Really, we're talking about people as well. It's the people that use that technology, how well trained they are, how motivated they are to adopt the technology and actually use it in a very efficient way. And then finally, it's the workflow, it's the process. So all 3 of these parts come together to help enact change. And there's a trend in the market for digitalization, digital data. And whether that's the fact that in the last 2 years, we've created 90% of the world's data. Imagine that for the last 2 years, we've created the last 90% of the data that's ever been created. It's phenomenal. And, you know, as consumers that use mobile phones and consumers that buy online, consumers that use Uber, it's amazing how much data is being created. Whether that's, you know, someone like Amazon that sells over 600 items every second somewhere. They sell, and this is probably old, it's probably 1,000 items every second. There's a ride-sharing company just like Uber in China that does 25 million journeys every day. They don't own any taxis. All they own is an app. And this company does 25 million journeys just like Uber every day. And then there's Spotify, the music streaming service. It's 1 billion streams every day. They don't own any shops that sell CDs or records or anything like that. They own an online platform with digital data, and people are listening to 1 billion songs every day. But in general life, in the area that we work, what's the digitalization that's happening? Well, one is BIM, building information modeling. The construction industry is going through a digital revolution. In terms of mapping, maybe for the last 10, 15, 20 years, we've seen the start of a revolution in information and digitalization in GIS. But actually, in most cases, even though we live in this digitalized age where we have Spotify and Uber, we put people into space, we still really use Stone Age tools. I often call it that I go to construction sites on a regular occasion, and we still build buildings and roads just like the Egyptians built the pyramids. And actually, you know, the worker of the past, which using these sorts of tools, is still very common. And actually, what we see as a global trend is people moving to the worker of the future, to using more digital tools to capture data, to position data. And this may seem like a distant future, but I'm sure there's a lot of people in this room that own a tablet, use a tablet in their day-to-day life. There's probably quite a few survey companies that are already using drones or UAVs to map. And we have 50, 60, 70 customers that already own a Pegasus backpack that are going around the world, mapping the world in the most efficient way. And for a lot of people, it's going from an old way of thinking, an analog way of thinking, to a digital mindset, a more digital way of thinking. And for me, I wouldn't trust this measurement. If you sent someone out to measure a room and you gave him a tape measure, that's fine. But how do you not know that he's doing that? Where actually for the cost of, you know, $50 now, $100, you can give them a technology that gives them an accurate measurement to within a few millimeters. It can connect to your phone. You can take a picture. You can email it in 30 seconds to the right person. So yes, this may cost you $2 to buy that tape measure, but how much does it cost you if that guy makes a mistake? Whereas for $100, you know you have a digital record of what's happened, and you can get it to the right person at the right time in the most efficient way. And actually, with reality capture technology, it's about connecting that real and digital world together. It's allowing us to bring digital data into your everyday life so you can generate deliverables for your customers to get paid, to make money, the most efficient way going forward. And it's about how we connect the office and the real world together. It's about, so we're not doing manual measurements, we're able to do digital measurements to connect those two worlds together. And ultimately, what this technology is aimed at doing is allowing you to deliver your project on time, on budget, and on specification, which is really, in a day-to-day life, what everyone wants to do. You have a job to do, you want to do it on time, you want to do it within the budget that you set yourself, and you want to do it within the specification that you've been set for. So where does the reality capture technology come in? Well, there's lots of different types of reality capture technology, and I'm going to talk about 3 of those different types today. We have 3D laser scanners, which you'll see outside at the Survey Tech booth. We also have UAVs available, and we also have mobile mapping devices. These allow you to take these reality capture technologies on a car, on a boat, even wear them, so you can be very portable, very mobile, and collect a lot of data very, very efficiently. But what do they actually give you? So one is point cloud. So hopefully a lot of people in this room may have seen a point cloud generated by a 3D laser scanner. But if you haven't, on the left here you see millions and millions of measurements. So our devices can scan up to 2 million points a second. So if you imagine maybe you've used a total station or theodolite in the past, where you point and you measure a point one at a time, where you're taking hundreds or thousands of points. Our most up-to-date scanner can scan 2 million points a second and can capture this room in complete 3D in 26 seconds. And it gives you this very accurate 3D point cloud, millions of points going forward. As well as that, we can collect imagery, 360-degree imagery, which gives you context. You understand the colors, the materials, what's going on. But we can also add other sensors. So some of our scanners and our mobile mapping systems have thermal cameras. So you can actually understand the heat and the cold to actually attribute that information to the data that you're collecting, which is very valuable these days. And the thing is, this isn't 3 different sensors. This is one sensor platform. And all that data is combined together so you have a complete 3D understanding of your environment. So where were we? So this is 19 years ago in the year 2000. This is one of our first scanners, and it's our first portable scanner. And you can see it's portable because it's got wheels. So you can wheel this around very easily. Of course, this was 19 years ago. It ran off car batteries. You had to have all this information that came with it. And just this last year, we brought out the RTC 360, which you'll see going there. So in 18 years, we went from our first portable laser scanner, which you can see is very large, could scan 1,000 points a second, to something that can now scan 2 million points a second, and is ultra portable and super easy to use. And this is the RTC 360. So I realize we haven't got sound, but the idea of the RTC 360 is about being fast, agile, and precise. So the RTC 360 can capture 2 million points a second at the click of a button. And really, the idea of it is to give you a technology. As you can see, you can place it in a rucksack. I actually, this last couple of days, actually flew with the RTC 360 from Dubai to Kazakhstan to go to a conference, to take it there, to do some scanning. And before, when I was in a survey company, I would have loved a device that I could just strap to my back, fly somewhere, drive somewhere, and actually capture something in 3D. As you can see, it's made to go on site. You take it out, you turn it on, and you can start to capture your world in 3D in such a unique way. And really the unique thing about it is it self-registers itself together. So when you have multiple places where you want to scan, you connect to your tablet and you're able to do some 3D laser scanning. I recommend that you go to the booth when you can and have a look. This is really cutting-edge revolutionary technology when it comes to laser scanning. So it's 2 million points a second. It weighs 5 kilos. It can scan up to 130 meters away. So from one point, 130 meters away. And it has this in-field registration. So this device here has 5 cameras. And these 5 cameras track its position, so it allows it to register itself together. And it really is the most fast, agile way to capture 3D point cloud data. We actually have more than one different type of 3D laser scanner. We have our BLK 360, which again you'll see 2 or 3 of them out in the stand. And this is 1 kilogram, about the size of a Starbucks coffee. And at the push of a button, you can capture your 3D world in a matter of minutes. It can scan up to 60 meters, but then we have our, what we call our best-in-class, our surveying range of 3D laser scanners, the P series, which allow you to scan up to 1 kilometer in distance. And this is really about highways and infrastructure and mining when you have to capture a large amount of information. So as I said, these can scan up to 1 kilometer in range. You can do a complete 360 in 2 seconds. And really, we've got people using this in plus 50 degrees and minus 20 degrees all over the world. The BLK 360 is a partnership with Autodesk in terms of collaborating and bringing the data together. And again, we can connect it to our tablet. We can scan in 3 minutes, and we have a complete 3D picture of going forward. But actually, how do we capture larger areas more efficiently if we only have a scan? Well, actually, we have systems called mobile mapping systems. And these are just a few varieties of mobile mapping systems we have. So on the left, we have something called Pegasus. So Pegasus is a vehicle-mounted mobile mapping system that allows you to capture 3D data as you move around your city, your road, your rail. We also have the Pegasus backpack, which is a backpack-mounted mobile mapping system, which means you can walk around buildings, areas, and start to capture data very, very efficiently. We also have a Pegasus Stream, which captures above and below ground. So we can actually scan below ground and capture buried utilities at the same time. We also have a rail and a road solution as well. So in terms of what can the Pegasus do, this is just an example that was used in Italy, in Venice. So some of you may have been to Venice, but Venice is full of beautiful canals. And we were able to take this vehicle-mounted mobile mapping system, put it on a boat, and scan Venice. So the accuracy of this system and the ability for it to understand its position as it's moving around a city, even on water, we can capture very accurate 3D data. So this device here has a 3D laser scanner, and as it's moving along, it compensates that position as it's rocking on the boat. And the same can be done on a road, on a rail, on a quad bike. You can drive this thing around and it will capture accurate 3D data. So it will capture point cloud and imagery and use GPS technology that allows it to capture its position. So something like Venice, which would be very difficult to capture accurate 3D data, you can see the amount of information we can collect. And this was collected in about an hour. And you can collect, just by riding down the boat, turning the 3D device on, we can capture millions and millions of measurements of Venice. And this can be done on the road in Jordan or on the highways, on the rail, wherever you need it to be. So it's a really great tool for capturing large amounts of information very, very efficiently. And again, like I say, it uses GNSS or GPS to position itself in the world so it understands where it is. It captures using a 3D laser scanner. It has 360-degree imagery, and it can be worked on any vehicle. Like I said, it could be on a boat, on a train, on a car, anything you want. In terms of what do we do with that data, so once we've collected it, what do we actually do? So in most cases, people want to collect highway information. They want to do topographical surveys, something along these lines. We actually have a software called Road Factory, which automatically extracts that 3D information for you. So you go out and scan with the Pegasus, you run it through a piece called Road Factory, and that allows you to extract center lines, lane lines, barriers, clearances, and this is all fully automatic. So not only do you capture the data much more efficiently than ever before, you bring it back to the office, you run it through another piece of software, and it will extract all that deliverables that may be used to do with total stations and GNSS going forward. But what happens if you want to be more mobile? What happens if you can't drive through the city centre? Well, this is where we have something called the Pegasus Backpack, which we're seeing a lot of survey companies and engineering companies start to buy into, because it's a very quick and efficient way to map large areas as you walk around. So things like city centres, sides of roads, you can actually walk around and capture 3D data ultra efficiently. It works in exactly the same way as the Pegasus vehicle-mounted mobile mapping system, except that it's mounted on your back. It uses the same 3D laser scanning technology and GPS and imagery. And as you move around, it will start to collect 3D data going forward. So again, like I say, it has GPS, 360, it's 12 kilos in weight, and you can actually see the data stream live into it. It's an amazing piece of technology. And again, so this is an example of some of the data that you can collect. So we have survey companies now that rather than sending teams of surveyors out with total stations and GPS, they actually send one person out with the backpack, they collect the data, and then back in the office, they start to digitize directly off that 3D point cloud, which is a much more efficient and in many ways safer way of doing it, because you're much faster in the field, you have less people in the field, and all your resources are there to generate those 3D or 2D deliverables directly from that rich 3D point cloud. And really this can be done in AutoCAD, in ArcMap, in any of your traditional survey software. You can bring this 3D rich data through into your world. The last technology that I want to talk about is the UAV. And ultimately, the UAV is now hugely popular. And there's thousands and thousands of different drones and UAVs on the market. And for Leica, we've partnered now with DJI, the Chinese manufacturer of drones, so we can provide a high accuracy, high-end survey solution for drones. And we've taken our high accuracy GPS unit, we've added it to the drone solution to provide a complete solution for our survey customers. So what is it? So it's the DJI platform. We add a Sony camera and we add all the various things to it. And really what the thing is we're selling is a complete solution. So if anyone in this room has a drone or a UAV, you'll know that you have to go out and buy the drone, you often have to go out and buy the camera, you have to buy the software, you have to buy the service, With this, with Leica, and with our partners, you buy the complete solution, all in one, ready to go, ready to use. But what can you use UAV data for? So one is topographical surveys, also volumetric surveys, whether it be ortho photos, elevation DTMs, digital terrain models, or 3D models, or even just to generate that 3D point cloud. So that's the technology. Now I want to talk a bit more about how you would use this data. Because actually, the technology is one thing, but what can you do and generate from the 3D information? So if you're in the plant industry, maybe you want to go out and you want to calibrate or do tank inspections. So in the plant world, this is very common as a deliverable. So now, with a 3D laser scanner, you can scan the inside or the outside of a tank, run it through software, and it will give you a heat map, an automatic heat map of the deviations and the specification for creating a tank inspection from that device. This is much quicker, more safer, and a better result than you would ever get with a total station before. And actually, using the scanner, we can invert it and put it inside the tank to scan inside. This is actually a 3D scan, but what people are doing now with plants and mining industries is they're scanning their plant environment to create a facilities asset register. They can actually go out there, scan, understand what pipes, what assets they have, and they can start to tag it and add it to their asset information register. And this is valuable for them because they need to understand what their plant looks like, what condition is it in, and actually scanning is the most efficient way to do it. And actually, you can actually do this very efficiently with the backpack, walking around plants, collecting data, and understanding what the plant looks like in 3D world. The same data we can start to extract 3D models from. So this is a similar data set. With a few clicks, you can actually extract the 3D pipe run just by clicking this, and it automatically will fit pipes to the point cloud to generate 3D models for you. So not only are you collecting that 3D data, you can extract the 3D geometry for it to deliver to the customer. So you use this 3D data as a basis for your 3D design, for your 3D asset going forward. Whether you're in the construction world, one is as-built modeling. So many times now we're talking about scan to BIM. So here we have some scan data, and inside Autodesk Revit, it allows you to create 3D models from the point cloud. And this is a hugely popular deliverable now, where companies are starting to use BIM to design and produce their construction. So using the point cloud here, you can actually physically snap on the points and create a very accurate 3D model directly from the point cloud. Imagine before when you had to do this with either total stations or you had to do this off existing 2D plans. It was very difficult, very time consuming, and often very inaccurate. Now with the point cloud and the 3D laser scanning, we can capture it very quickly and we can generate 3D models just as efficiently. So this is an example of using a laser scan to generate a 3D building information model. And you can actually use this building information model through the life cycle of that project and start to generate even more information. In terms of construction, flatness or verticality is often very important. So when you're scanning a concrete slab or you're scanning an elevator, you want it to be flat or you want it to be vertical. So before, maybe again you used old-fashioned technology. Now you can use 3D laser scans to scan the floor and run it through an automatic analysis to understand whether the floor or the concrete is flat. And this is a really popular deliverable now for construction companies that need to ensure that the concrete that they've laid is perfectly flat. There's also construction verification. So this is where you want to understand whether the 3D model has been constructed correctly. So you can see here that we have the 3D model. This is something that's been designed by a piping company. They've sent it to site to be constructed. Someone's installed the pipe, and you can see that actually they've missed a complete section of that. So they've used the 3D scanner, this is the BLK 360 in this case, to identify where there's missing components on site. And this allows you to spot errors, it allows you to stop expensive mistakes from happening. So within a few minutes, you can take a 3D point cloud with the BLK 360, bring it into your 3D design, and actually you can start to spot where there's missing components. And this is very, very valuable for construction companies because they're wasting a lot of money and a lot of time on companies not doing the right thing when it comes to construction. The other thing is clash detection. So ultimately, I'm a designer and I'm designing a new piping system for this room. I need to understand whether that piping system is going to fit inside the room. I have outdated 2D plans, so what I can do is I can scan it with my BLK or my RTC. I can then take my 3D design and I can see if my design is going to fit inside this room. And again, this stops me from making a costly mistake in the future. I can actually virtually build and design and construct my model virtually before I bring it to site, stopping mistakes from happening. And again, this allows me to really stop these costly mistakes from happening on site. If I'm looking at engineering and infrastructure, we can actually use the 3D point cloud to validate complex engineering projects. So this is a project called Museum of the Future in Dubai. It's a complex steel structure. It's about 8 stories tall in terms of size, and it's made up of these large steel tubes that are welded together. And on a daily basis, they would use 3D laser scanning to validate the construction of these tubes, because they knew that if any of these tubes were constructed in the wrong way, then at the top, when they begin to connect it all together, they would have a serious problem. So they're using it on a daily basis to validate the engineering tolerance of what's being constructed. And it's to visualize such a 3D complex structure is very difficult without 3D laser scanning. When you want to map large infrastructure, so this is an example of quite a complex road structure, and this is my former company in the UK were asked to do this. They had to survey a complex junction like this, and they were told, how long would it take you to survey that using total stations and GNSS? And with closing of the road, with all the different teams they had, they estimated it would take 3 to 4 months to map all this information above and below the road structure. So they invested in mobile mapping technology. They bought a Pegasus 2, and they were able to map this whole system in 4 hours. So what took them 3 or 4 months before, they were able to map it in 4 hours, and to capture this complex 3D world using a mobile mapping system in just under 4 hours. So taking that information through into AutoCAD and ArcGIS, they were able to then extract that 3D data to deliver to the customer. The other thing we can do is we can start to validate 3D engineering construction. We can actually do heat maps and validate the 3D model against the point cloud to give you the accuracy of your construction, of your engineering. So you can see here, red is bad, green is good. So you can see that our tolerances here may be out. We might have a problem here because we haven't constructed our bridge in the correct way. As well as that, using things like the Pegasus backpack, you can actually capture both above and below ground very efficiently. A lot of the Pegasus backpacks in the world are used to map underground tunnels, underground road networks and rail networks. So here you can see an example of mapping the above ground and the below ground at the same time to give you an understanding of this complex 3D world, to start to extract that 2D and 3D deliverables that maybe you're used to delivering before. As well as that, with the mobile mapping system, what we can do is we can look at the road conditions, and actually using the mobile mapping system, we can extract all the damage and the cracks that come from the mobile mapping system in an automatic way. So this is from point cloud information. We can scan the road and actually run it through our system to understand damage. And for municipalities and a lot of projects, this is very, very important because the deterioration and the damage to roads is costly, and it costs a lot of money not only to repair, but also it costs a lot to the infrastructure to run this. So imagine you could take your vehicle-mounted Pegasus 2, drive through a man, and then you can actually understand and capture your road quality information and actually generate a 3D deliverable that allows you to understand exactly where the damage on the road is. And you should be doing this on a regular basis to understand where the road is deteriorating, where does it need fixing, is there a problem, do we need to change something, do we need to relay the road going forward. And again, This may have taken a lot of time before using traditional methods. Now with mobile mapping systems, you can drive around, capture the data, and then run an automatic software to extract that information. And again, once you have that mobile mapping information, it's a lot simpler to start to extract this information. Imagine being a surveyor, going out there with a total station and a GPS, trying to capture all this information safely in a busy road environment. Now, taking a mobile mapping system out there, you can go back to the office, sit in your AutoCAD world or in your ArcGIS world, and you can extract your center lines, your barriers, your edge of road, and deliver your traditional 2D, 3D deliverables, but in a much more cost-effective way going forward. So really you can start to build these high-definition city maps. In environments where you need to capture maybe complex environments with tight spaces, you can use Pegasus Backpack. And this is an example of doing a traditional topographical survey in a maybe more challenging environment, and you can just walk around with your backpack, capture it in under a day, bring it back to the office, and then you can start to extract your topographical information directly from the point cloud. The last example I want to talk about is the clearance analysis. So once we have mapped our city, we can actually run clearance analysis investigation to actually understand whether something can fit through, whether it's abnormal loads. We can actually understand, is it going to damage our city as we travel around it? So the one thing I'd like to say is, with reality capture, you capture it once, but you can use it multiple times. Going out and mapping a city like a man, you don't have to just look at the pavement, at the roads and the deviations. You can actually run a clearance analysis. You can extract the topographical surveys. It's very, very, very efficient to capture it in the field, but also to extract those 2D and 3D deliverables in the office. I thank you for listening. Thank you very much. Have a good day, and thank you.